Hey, welcome to lesson number 4 in your book. This is the slope formula we're looking at today. We're going to start by doing the review, and then we're going to develop the slope formula. So first of all, slope is the measure of how steep a line is. So it's a measure of the steepness of a line. Slope is the ratio of the vertical change. So remember, yesterday we called it the rise, and we divide that by, the vertical change over the horizontal change. So we divide it by what is called the run. And a line segment which rises from left to right, and so going upwards, kind of like A to B here, this would have a positive slope. So positive slope. And a line segment that does the opposite and falls from left to right, like C and D on your book, this would be a negative slope. So a horizontal line segment has a slope of 0. So if there's no rising and it's just kind of like a flat line, then we would say that has a slope of 0. A vertical line segment, so a line segment going straight up, would have an undefined slope. And remember, the reason for that is because there is no run, so we're technically dividing by 0, and you can't divide by 0. And the slope of all line segments on the same line are equal. Now, when we develop the slope formula in this example here, we want to calculate the slope of line segment AB using the slope rise over run. So if we start here, we want to count how far up we go to get to B. So if we were to, this is kind of how I like to do it, draw a horizontal and a vertical line, and going straight up and sideways, up 1, 2, 3. So we have a rise of 3, and we have a run of 1, 2, 3, 4, 5, 6. So 6, which would reduce to 1/2. Now we want to list the coordinates of the endpoints of line segment A and B. And so if we look at this coordinate here, this goes up by 1 each time, starting from 0 down here, going up to 5. And so at A, we are going to be at 8. So 5, 6, 7, 8. That's my y-axis, but my x-axis is starting at 0 down here and going up to 10. So this is just the first plane, or the first plane of our Cartesian plane. And if we count for A here, then that's going to be at 1 and 8. And for B, right here, my x-axis is 7, and my y-axis is 1 above 10 is at 11. Now, how can the rise of line segment AB be determined using YB and YA? Now, YB right here. So this is like, so that's point B, and that's the Y value for point B, and this is the Y value for point A, which is 8. And what it's asking is, how can the rise of the line segment be determined using YB and YA? Well, if we were to look at YB and we subtract YA, this would be 11 minus 8. YB is 11 and YA is 8. And that is equal to 3, which is also equal to our rise. And we could do the same thing for the x values on our line segment. So for XA and XB, where I had XA1 and XB 7, say XB minus XA is equal to 7 minus 1, which is equal to 6. So then what we could do is we could put this into a formula where we could calculate our slope. And when we do that here, slope then is equal to the rise which was 3, and that would be yb minus ya in this case, divided by the run, which would be xb minus xa. So now we can calculate the slope of the line segment AB using the formula that we just came up with. And so let's try plugging all of that in. So slope is equal to yb minus ya. And it's always a good idea to rewrite your formulas so you know what substitutions you need. And yb was 11, ya was 8, and xb, and xa was 1, which gives us 3 over 6, or 1/2. Now we want to calculate the slopes of the lines C, D, and EF using the method in A, and we want to verify using the formula from E. So first of all, using the method from A, that means we're just going to be counting the slope. So let's first look at line segment CD. That's this one right here. So slope of CD is equal to, and remember, we're going to start with using the method in A, which is just to count the rise or the run. Right? So that's rise over run. And sometimes just using rise over run is a lot faster, but it's not always going to be the case. All right, so starting with rise over run, and this is falling from left to right, so we know it's going to be negative. So it's going down and then over, and so it goes down by 1, 2, 3. So it's got a rise of -3 and a run of 1, 2, 3, 4. So that's -3/4. And we'll do the same thing for the slope of E and F. So it's going up, and then there we go. So it's all on the screen, and then that's going to be a positive slope. So slope of EF, slope F is equal to rise over run. And it has a rise of 1, 2, 3, 4, 5, 6, 7, 8, 9. And divided by 3, which is equal to 3. And last, we want to choose 2 points. I'm just going to do it for 1, just so this video doesn't end. And so I'll do it for CD. I'm going to choose point C and point D. And if I use the slope formula, so slope of CD is equal to yb minus ya divided by xb minus xa. So yb, we'll call that, or sorry, we should use D and C instead of. YB is 2. If this is 0, and this is also 0 on the y-axis, we're going up by 2. So YD is 2 minus C, which is 5, which are negative, and XD is 6, subtract 2, -3 over 4. Now we just developed the slope formula, and in math, the letter M is used to represent slope. So instead of writing slope each time, we could just write M. And later on, when we start using slope more, especially in linear equations, then you'll see why you've seen M before in the past. This is one way we could write it. So M is equal to y2 minus y1 divided by x2 minus x1, or like this. But probably 100% of the time you're going to see it written like this, not like this. So, except for in a few examples, we might see it written this other way. But rarely do you see the slope formula written. But just in case you do, especially in this book, let's go over this example. So find the slope of a line which passes through the points G at -3 and 8, and H at 7 and -2. So first of all, we want to identify, well, actually, we don't really need to, but usually, if you're not given this formula right off the bat, then you'll want to identify which values you want to be 2 and 1. And it doesn't really matter, but it does help. Well, you do just need to make sure you're being consistent in the coordinates that you're plugging in each of these points. So they're telling us directly which value they want to be placed here. So YH is -2. Okay, so here's H, and here's the Y value for H, and that's -2. So they want us to plug -2 into this spot. And we need to subtract Y of G, and here's my G point, and that's the Y value there. And we're subtracting 8. And we want to divide it by XH minus XG. So here's my H point, or my H coordinate, and here's the X value there. And so that's going to be 7 subtract -3. -2 minus 8 is going to be -10, and 7 subtract -3 is going to be +10. And -10 divided by 10 will give us -1. And so our slope here is -1. We have example 2. And in example number 2, we have 3 individuals. We have Eleanor, Bonnie, and Carl, and they're calculating the slope of a line segment with the following endpoints, E and F. So E is at 15 and 8, F is at -10 and 6, and their work is shown below. Their answers are all different. So Eleanor gets an answer for her slope to be 25/2. Bonnie gets 2 divided by -25, or sorry, 2 divided by -25, and then Carl gets 2/5 as his answer. So the question is, who is right and what mistakes did they make? So let's just comb through their work here. We have E and F, and so if we were using the equation above, MP and Q, then what we need to do here, so MPQ or MEF, they all started the correct way, MEF, MEF, and MEF. But when they're actually subtracting it, and so if I were to write the formula down here, MEF, then their work should then look like this. Should be Y of F minus Y of E divided by X of F minus X of E. Now, at this point, we then need to make sure that all these coordinates, F and E and F and E, are in the right spots. And so if we look at the work, the F coordinate is at 6, and that's the Y value there. So this is going to be 6 minus 8. And then for the X values, it's going to be -10 minus 15. So 6 minus 8, we get -2. And -10 minus 15, we get -5. And at this point, we're going to get 2/25. So who's right? Well, the answer is none of them are correct. And let's see the errors that they made along the way. So first of all, Eleanor, what Eleanor did incorrectly was she switched around the X and Y values. So she was dividing the run divided by the rise instead of the other way around. Bonnie was pretty close, so she had the 6 and the 8 in the right place, although she had the 15 and the -10 mixed up. So this should have actually been the other way around. So Eleanor made this mistake where she got her X and Y's mixed up, and then Bonnie made the mistake where she got the coordinates for the X's mixed up. And then Carl, he made a similar mistake to Bonnie. He got the 8 and the 6 mixed up. And so you just got to make sure you're being consistent with And another thing that Carl did was he forgot the negative here. Okay, so he would have been correct if he remembered the negative here, and also, yeah, that he would have been fine otherwise.